certain category. And so today we're doing generalizations or conjectures about similar triangles. So let's go with group 3. What was one conjecture that you guys came up with that all similar triangles hold?
They must share all their angles.
All right, good. Okay, awesome. Group 4. Okay, hi. Out of my phone.
All these sides must be proportionally equal.
That says proportional for anyone who can't read my handwriting. Group 2. Any different conjectures?
You said the second one.
You said the second one. Group 1?
Yeah, those pretty much.
Those two? Okay, this is fantastic because these are the two main conjectures about similar triangles. So if you were to actually go out into a field and try to measure some trees, what would you try to measure the angles between the sun hitting the tree and the actual shadow of the tree? Or would you say that all the sides must be proportional if you already know some parameters already?
Size.
Exactly. Sides are generally more helpful when actually putting this into practice. So let's go through a couple, or let's go back to this tree problem. If I was out in the field and I became very skinny with a bulbous head, and I cast a shadow that was, it's not going to be 6 feet. Let's go with 4 feet. And I know that I am 6 feet tall. Now I'm standing next to a giant pine tree. I can draw pine trees, don't even worry about it. Wonderful pine tree. And these are obviously not to scale, because this pine tree is huge. And it casts a 40-foot shadow. And we've measured this with a meter stick, or yardstick. What can we guess about that, the height of that tree, using proportions and heights?
60 feet.
60 feet, awesome. How did we come up with that?
4.
So 4 is to 40. So if we go 4 is to 40, it's equal to 6 over question mark. Right? Does everyone understand where that comes from? If we set up shadows equal to each other and heights equal to each other, we can come up with what will eventually get to be a proportion like this. Now, does anyone remember how to, so this one was pretty easy. So if I were to make these, if I were to make this 32 feet, would being able to guess that this is 40 to 40, would that work as well as with 40 to 32 feet? No, because it's not as easy. It's not times 10. So what we could have done last time was just recognize that that would work. But with this one, we have to set it up with this setup. Now, does anyone remember what we went over last week on proportions, on how to solve them, how to solve for x in this equation?
Cross multiply.
Yes. Cross multiply and divide. So what does that mean? So if I go so cross multiply. So if I go 32 times 6, then what do I do? Divide by 4 times x.
No. Instead of equal to.
Oh, equal to 4x. Okay, so So that works well for that. And I'm aware that my tree example is mostly, who's going to go out and measure trees, right? So can anyone think of any other reasons that we would use proportions in either not necessarily everyday life, but if we were all engineers? We're all going to be engineers, right? Of course.
Building height?
So if you come up with something as your
Buildings?
buildings.
How buildings are?
Uh,
I guess. Is it a guess?
Yes, buildings work very well to measure the heights of trees, or measure the heights of trees. If you know measurement, it's very good to project to a height of the building. Anything else that we can come up with? Yes.
Finding distance across a body of water.
Perfect. And what do you mean by that?
Well, if I'm an engineer,
You're an engineer.
you said I was an engineer, right?
Yes.
So if I'm an engineer and I want to build a bridge across a body of water, and I don't necessarily want to swim across that body of water, I wonder if there's any other way I could do it.
Making the body of water bigger. So, there we go. And then bridge across. Trying to think of something that doesn't involve calculus. Come on,
Find a tree that's shadow reaches across the
So, how about we use what she said? We have a big factory here,
There we go.
and we know the height of this factory. We know the height of the factory is 60 feet tall, and the height of this shadow just barely doesn't quite reach it. And Leanne, how tall are you?
5'5".
So if we know that Leanne, also very skinny.
Excellent.
Is 5'5".
Excellent. Nice.
And her shadow casts length of 4 feet. What would the equation to find the width of the river be for this example? I have an answer. Well, let's go with this real quick. 5 over 60 is
5'5" is it 5.5?
4 over x.
5 be less than 5.
Ah!
Too bad I'm
This
not
is what I was going
so-
for.
Yeah, would have been.
When working with proportions, you have to make sure that you're working with units together. You can't, or you can make units, you can proportionalize inches to feet, but you will have to end up converting units. And so for your homework tonight, we come up with some other explanation that we didn't use that would work with proportions and any problems that you would have with it. So with these examples, what would a problem be? Trying to come up with finding the length of this river using this.
How far away from the river it is?
That is a very good one. Also, what if it's dark?
Oh.
Can't measure shadows if it's dark.
We shouldn't be working after dark. It's dangerous.
All right. So tomorrow, hopefully, we'll all come in with an example of how we can use proportions in either our everyday life or why anyone else would use proportions and any potential problems that you would have with it. Okay, does everyone understand what's going on?
Yes.
Awesome, you're dismissed.